This video is going to be about right triangles. It's going to be about two specific kinds of right triangles, and they're known as special right triangles. So special right triangles are two types of right triangles that have very specific things about them that are always the same, and if you can memorize it, it makes your life a lot easier. So the first kind that we're going to do is an isosceles right triangle. That means both of the legs are the same length, and the hypotenuse obviously is longer than both of them. Okay, in this isosceles right triangle, that's means both sides are the same, and we have a right angle in the middle. Well, something else that you should know about that is that these two angles are congruent to each other. And if those two angles are congruent to each other, you should know that they both equal 45 degrees. So this is an isosceles right triangle. But more importantly, for us as a special right triangle, this is called a 45, 45, 90 right triangle. So whenever you see this, you see the 45s, or you see that the sides are the same, and it's a right triangle, you know that it's a 45, 45, 90 right triangle. And the cool thing about it is that once you memorize a pattern that I'm about to show you, you won't have to do the Pythagorean theorem to figure out the side lengths of this thing. Okay, so in this triangle, you can see that it has two sides, and the two sides are the same length. So we'll say that this side is x. Well, that means this side would have to be x. Now, if we wanted to find this third side, this hypotenuse, well, it would have to be equal to, if we go by our Pythagorean theorem, a squared plus b squared equals c squared. That's this side, the hypotenuse. Well, it would have to be equal to x squared plus x squared, and that would equal c squared. Well, x squared plus x squared is 2x squared, so 2x squared equals c squared. Now if I'm going to rewrite that up here, c squared equals 2x squared. Now to find out what the c or the hypotenuse equals, I want to take the square root of both sides. So I'm going to get that c equals the square root of 2x squared. Well, just like we would do the square root of 72 is the square root of 36 times the square root of 2, so that equals 6 times 6 times the square root of 2, and that would give us 6 square roots of 2. We're going to do the same thing with this. I can't do the square root of 2, right? So if I do the square root of 2x squared, well, that's the square root of 2 and the square root of x squared. I can't do the square root of 2, so that's going to stay like it is, but the square root of x squared is just x. So c, the hypotenuse, is going to equal x times the square root of 2. And that is what this 45, 45, 90 right triangle pattern is that you're supposed to memorize. All it says is that if you have a right triangle that's a 45, 45, 90 right triangle, then the legs are going to be a certain length, and the hypotenuse is going to be the square root of 2 times whatever that length is. Let's do a quick example. We'll draw a 45, 45, 90 right triangle. So this will be 45 degrees, 45 degrees, and a right angle here. And I'll say that this length is 5. Okay. What is, and we'll call this A, B, C. What is the length of AC? Well, in past problems, you would have to do 5 here, then you'd have to put a 5 here and do 5 squared plus 5 squared, right? So 5 squared plus 5 squared equals c squared. And you do 25 plus 25 equals c squared, 50 equals c squared, and then you'd have to square root both sides, so this is the square root of 50 equals c. So the square root of 50 You can break that apart into the square root of 25 times the square root of 2. Well, the square root of 25 is 5, so I would know in this problem that c equals 5 times the square root of 2. Well, that's not that hard, but if you would look back at what we originally said, that this side would be x square roots of 2, well, this side is the x, so x equals 5, x equals 5, so this side, if x equals 5, x square roots of 2 is 5 times the square root of 2. So instead of doing all that work, if I know what x is, just plug it in there and I'm done. And it gets a little harder. We have to go backwards sometimes, but we'll practice it a lot, so don't worry. The next kind of triangle is another special right triangle. It's very specific. So this isn't for every right triangle. This is just for these specific ones that we're writing down today. This one is a 30, 60, 90 right triangle. Okay, so this is 30, 60, 90 right triangle. And this one has a similar pattern. It's not quite the same as the other one, but it's still manageable. And to show you what that pattern is, I'm going to start with a little different kind of triangle. I'm going to start with the equilateral triangle. So here is an equilateral triangle. And you know that this is 60, 60, and 60 degrees, right? Well, if I split it in half, which is split it just like this, okay, I would basically create this triangle. So I'm going to split it in half. Just pull off this half. Now let's pretend that this is what all we have here. I know this is 60. How much is this? Hopefully you see that when I split this in half, that makes this 30. Now let's assume that I know how long this bottom is. So I'll say this bottom is x. So that's this bottom is x. And this bottom is x. Well, how long is this side over here? Remember, if this is an equilateral triangle, the whole bottom versus half of the bottom, well, this would just be double what this is. So instead of x right here, this is 2x, right? So we just need to find out what this would be, and then if I told you this was 3, this would be 6. If I told you this was 7, this would be 14. And then to find out this other side, we're going to do the Pythagorean theorem. Okay, so we're going to do x squared plus b squared, right? Because I don't know what it is, so we'll say that this is b for now, equals 2x squared. So I get x squared plus b squared equals 4x squared. Now remember, I'm trying to find out what b is. That's this side over here, right? This is a, b, c. So I'm going to try to get the b all by itself. All right, so now I have this, 3x squared. Well, to get rid of the squared, I square root, and I get b equals. Now I know the square root of x squared already because I did it way up here, right? It was just x. So b equals x times the square root of 3. And I'm not going to be able to figure out what the square root of 3 is because it's not a perfect square. So I'm just going to leave it like that. It's a prime number. Can't get any smaller. So this side over here is x times the square root of 3. And that's our pattern for our 30, 60, 90 triangle. So the shortest side across from the 30 degree is x. The longest side, the hypotenuse, is 2x. And the other leg that's not the shortest and it's not the longest, it's the middle one, is x times the square root of 3 long. So let's take a little quick example. Look at how that would work. All right, so let's draw a 30, 60, 90 right triangle. Okay, so we're going to have, remember the 30 is the small one. 60 is the big one, and 90 goes right there. And let's say that this side over here is 4. Okay? What are the missing side links? Okay, so how long are they? Well, in the past, we wouldn't be able to tell this at all because it only tells us one side of the triangle, and we can't do the Pythagorean theorem unless we know both sides. But we do know our 30, 60, 90 pattern here, right? This is the 90, this is the 30, 60, and we know that it goes x, 2x, x times the square root of 3. Okay, so I look at this and I think, well, what's across from the 30? Well, that's x, right? So across from the 30, x equals 4. Right, well, what's across from the 60? Let's see, across from the 60 is x times the square root of 3. So if x equals 4, x times the square root of 3 equals 4 times the square root of 3. Okay, so that must mean that this is 4 times the square root of 3. And then across from the 90 is 2x. So across from this 90, 2x, if x equals 4, 2 times 4 is 8. So this equals 8. And I just memorize these things, and I can just answer these questions without doing any work, really. So anyways, that is special right triangles. It's going to get a little harder, but not much, so just do your best to try to memorize this for tomorrow.